Hello dear learners, in our today's class we have to talk about the conductance unit. So today in my class I will start with the unit of conductance. Here we will talk about all the concepts which relate to the properties like the conductance, the conductivity, the limiting molar conductivity and the other things of the electrolytic solutions. So in this unit of conductance, the first important topic comes about the laws of electrolysis. So first we have to understand that what is the meaning of electrolysis. See, in the electrochemistry, we have certain reactions wherein the chemical energy is used to generate the electrical energy. We say that there are certain reactions in electrochemistry where we are using the chemical energy and we are generating electrical energy out of this. So these are the reactions which are also referred to as electrochemical reactions, and the best example of such reaction which occurs is that which is occurring in the galvanic cell. In the galvanic cell, basically we do the chemical reactions to generate the electrical energy. Then there are certain other reactions where we are using the electricity from outside to carry out certain kind of chemical reaction. And this type of reaction is called as electrolytic reaction. So electrolytic reaction is that wherein we are using the electricity to bring about a chemical change. And where are we doing that? We are doing that in an electrolytic solution. And this happens on the passage of electricity through that solution. And this whole process is referred to as electrolysis. So when the current is passed, the ions in the electrolyte move to their respective cathode and anode. Suppose we have any electrolytic solution. Now this contains certain cations also, and then there are certain anions also, and then we have here two electrodes emerged, one of them being anode, the another one of them being cathode. So when the electricity has been generated, the particular compound, let's say this is my electrolyte, so it starts dissociating into its own ions, be it cations and anions, and then these ions will start moving towards their respective poles. So suppose here we have the anions, so these anions will start moving towards the anode and the cations will start moving towards the cathode. So this process or this phenomena is called as the electrolysis. Now what happens is as soon as these ions they move to their respective poles, they will undergo certain chemical reactions. Either they will undergo the oxidation reactions or they will undergo the reduction reactions. Because of these oxidation and reduction reactions, either these chemicals will deposit at their respective electrode or they will be released into the solution from their respective electrode or they may also be liberated out as a gas. So these are the certain properties of the electrolytes which we use in the solution. So when we are passing the electricity through that electrolytic solution, the electrolyte will be dissociating into cations and anions, and these cations and anions will then move towards their respective electrodes, and thereafter going to their respective electrodes, they will either be getting oxidized or they will be getting reduced, and as a result of that they can be either deposited upon the electrode or they can be released from the electrode into the solution or they may even be liberated as the gas. So here the Faraday's law which were proposed by Faraday are actually trying to provide the quantitative relationship between the amount of electricity passed and the quantity of substance deposited or liberated. So here for simplicity, we are just going to consider one scenario wherein, let's say, a substance is deposited on its electrode. So we will, on the basis of this only, we are going to talk about the Faraday's laws. So how much quantity of electricity is required, or how much quantity of current is required to deposit a certain amount of substance on the electrode. So this is what was proposed by or put forward by Faraday. So this he kept forward by the two laws which he had given. So we have to talk about the two laws, that is the Faraday's first law of electrolysis and the Faraday's second law of electrolysis. So now we will discuss about them. Okay, before that also we should know that what is the value of 1 Faraday. So 1 Faraday is equals to 96,500. So this is the numerical value of 1 Faraday. And this 1 Faraday is the amount of charge which is required to deposit or liberate approximately 1 mole of electrons or 1 mole of ions. Now let's talk about the Faraday's first law of electrolysis and what does it say. Faraday's first law says that the mass of substance which is either deposited or liberated. Now let us only talk about deposited. So the mass of substance which is deposited at any electrode is directly proportional to the quantity of the electricity which is passed through that electrolytic solution. So mass is directly proportional to the quantity of electricity which is passed through that electrolyte. Means more the electricity passed, more the mass will be deposited on the electrode. We also know that Q, that is Q, here Q refers to charge, is equals to I multiplied by T. So we can also say that mass is directly proportional to IT because we are replacing this Q with IT. And if we remove this proportionality sign, so we get a proportionality constant, that is Z. So we get ZIT. So this Z is here the constant of proportionality, this I is the current, T is the time, and M is the mass. So Faraday's first law simply says that more the quantity of electricity you are providing to the electrolytic solution, more will be the amount of or the mass of a particular substance deposited on a particular electrode. Okay. Then afterwards, what conclusions we can draw from here? So some important conclusions which we can draw from this part, what Faraday was saying, is that if I talk about cations, which are positive in nature, so these cations, they will move towards cathode. Now cathode is a negative electrode and there they will be reduced. And if I talk about anions, these anions are negative in nature, they will move to anode. The anode is positive and there they will be oxidized. So what I mean to say is that suppose we talk about cations. So let's say this is one cation. So as soon as it moves to its respective electrode, it will get one electron. So what happens here? Uh, wait, I'll draw it again. So this is my cation. So it is now receiving one electron and then it will be reduced. So this is your reduced form of A. Okay. Similarly, this will be my anion, and as soon as it reaches anode, there it will be oxidized and it has to release this electron. So this is what happens. Either the oxidation can happen or the reduction can happen, means either of them can happen. So this is either the reduced form or the oxidized form of the cation and anion. Also remember that more the charge is passed, more will be the number of ions discharged. Now we should talk about the second law of Faraday. So first law is very simple. It says that the mass of a substance deposited or liberated will be directly proportional to the quantity of electricity which is passed through the solution. Now if I talk about the second law of electrolysis of Faraday, it says that if the same quantity of electricity, suppose we have different electrolytic solutions, suppose here we have, let's say, solution A, then here we have solution B, then here we have solution C. Now if I say that if the same quantity of electricity, suppose all of them, let's say, yes, let's say all of these solutions are connected in series through a battery. Okay. So in that condition, what will happen is that if the same quantity of current is flowing in all of them, so now what happens is that the amount of substance which is deposited in the different electrolytes. Now we know this, that here whatever the electrolyte will be present, its amount of substance deposited on the electrode will be different from the amount of substance which is deposited here. Suppose here more deposition has taken place, but here only less deposition has taken place, and here the highest amount of deposition took place. So the amount of substance which will be deposited at their respective electrode will be proportional to their equivalent weight. Now here comes the concept of equivalent weight. What is the meaning of equivalent weight? whatever is your molar weight divided by the n factor. This is our equivalent weight. So more is the equivalent weight, more is the substance deposited. This is what Faraday's second law says. So suppose here I take three different, let's say three different electrolytes. So suppose here I am taking NaCl, here I take KCl, and suppose here, although not possible, let's say I am taking another like RbCl. So we know that in group 1, these come like in the ascending order. So this will have the lowest molecular weight or the molar mass. It will be having more and it will be having more. So see, what I'm trying to say is more is the equivalent weight. As the equivalent weight increases, the amount of substance deposited will also increase. Deposition will increase here. When we are passing the same, here see, current is same. The current is a constant quantity here, and the time is also a constant quantity, because for the same time we are passing the current in the three different electrolytic solutions. So what we can say is, what we can conclude here, we can say that M1 will be directly proportional to E1. Similarly, M2 will be directly proportional to E2. Now, if we divide these two equations, 1 and 2, so the proportionality sign will be removed and it will be equal to M1 upon M2 equal to E1 upon E2, where E is already your molar weight upon the N factor. So we can also write it as M1 upon M2 equal to capital M1 upon N1 upon capital M2 upon N2. This N factor will vary. Suppose I take sodium, so for it the N factor will be 1. But if I take magnesium, for it the N factor will be 2. If I take suppose copper, for it the N factor will be 2. If I say calcium, for it N factor will be 2. If I take aluminium, for it N factor will be 3. So it depends. So this is simply the Faraday's second law of electricity. Okay, now we have to talk about some of the general terms which are common to the unit of conductance. So starting on with the first important and general term, that is resistance. What is the meaning of resistance? It is also referred to as capital R. Resistance of an electrolytic solution refers to, or it is a kind of property of that solution, of that electrolyte, to oppose the flow of electric current. So this is what we call as resistance, and the formula for resistance is rho L upon A. We know the unit of resistance, it is ohm, and this particular rho is called as resistivity. Resistivity. So this is the resistivity, and this is a constant here. And if we try to derive the formula of resistivity, it will be equal to R A upon L, and the unit of resistivity will be equal to ohm meter. Second concept or second important term which comes is conductance. Now conductance is represented by G, and it is simply inverse of resistance. Means it is the ability of material to allow the flow of electric current through it. And if I talk about its unit, it will be equal to ohm inverse. It can be also called as mho, that is inverse of ohm, or it can be called as Siemens. So it will be S. And since it is inverse of resistance, so we can, resistance is rho L upon A. So we can write it as 1 upon rho L upon A. So it will be equal to A upon rho L. We can write it as 1 upon rho multiplied by A upon L. And this 1 upon rho can also be written as kappa. And this kappa gives our third and the most important term, that is conductivity. So this is your conductivity or kappa. And kappa is simply 1 upon rho. That is the inverse of resistivity. Now conductivity is nothing but the conductance of 1 meter cube of solution. If you are taking standards, so 1 meter cube of solution placed between two electrodes, each of area 1 meter square, and they are placed 1 meter apart from each other. So that is your conductivity. The unit of conductivity will be equal to Simon centimeter inverse. It can also be equal to Simon meter inverse. It depends what you are taking. So when the conductivity of an electrolytic solution is measured, the electrolyte is placed between two platinum coated electrodes. Also remember this, that whenever we are trying to measure the conductivity kappa, generally in the experiments also we try to measure the conductivity of the solution. So that time when we are trying to measure the conductivity of that electrolyte, suppose here in this container I have electrolyte and here I have two electrodes placed. So always remember that the two of these electrodes will be coated with platinum. Although they may act as cathode and this may act as anode, but they are coated with platinum. Why they are coated with platinum? So that any of the chemical reaction can be avoided. We know that the chemical reaction can occur due to the deposition or the liberation of the particular ions or particular chemical substances from that electrolyte. So platinum here is acting as an inert material and it is trying to avoid the chemical reaction. So while we are measuring the conductivity of a cell, we use the two electrodes which are platinum coated so that the chemical reactions could be avoided. Always remember that if resistance is directly proportional to length, we know that as the length is increasing, the resistance will increase. So the conductance will be inversely proportional to length. Similarly, if the resistance is inversely proportional to the area of cross section, so here what should happen? The conductance is directly proportional to the area of cross section. As simple as that. Now, sometimes what happens is that we know the value of conductance and now we have to calculate the value of conductivity. So right now I only told you that what is the meaning of conductivity. It is nothing but certain dimensions associated with this conductance. For example, it is the conductance of one, let's say if we are taking it in centimeter, so it is the conductance of 1 centimeter cube of an electrolyte which is placed between two electrodes which are 1 centimeter apart, and the area of the cross section of both of the electrodes is 1 centimeter square. So we are adding dimensions to it. So it will be multiplied simply by the cell constant. And the cell constant is the dimensional constant of a particular cell and it can be represented as G star. So kappa is nothing but G multiplied by G star. And the unit of kappa I have already told you, that is Simon per centimeter. So if I try to take the value of here G, it is what? It is Simon. Now this should be centimeter inverse. So for centimeter inverse, it has to be L upon E. So conductivity or kappa is nothing but G multiplied by L upon E. And this L upon E is nothing but your G star or your specific cell constant. Now we have to talk about the types of conduction. There are various types of conductions which can occur. Conductions means nothing but the phenomena of passing of the current through the particular material. Now this conduction can be either metallic conduction, means the passing of current through metal, or it can be electrolytic conduction also. Now there are certain differences in the two conduction processes. See, matter is a solid and electrolyte is not solid. The ions are free to move here, right? So if I talk about metals, the highest conduction can be done by silver. Then we have the example of copper also. Then we have the example of aluminum also. So this is generally what the silver is also referred to as best conductor of electricity because of this only. For the electrolytic conduction, there are certain uh, strong bases as well as there are certain strong acids like NaOH can be there. Similarly, CaOH voltwise can be there. KOH. Here we have HCl. Here we also have H2SO4. So these are the strong acids and strong bases. Even the strong salts like KCl or the other salts also, like for example NaCl. KCl we should not consider. NaCl you can consider as a strong salt. So they can carry out the conduction process, and that's why because these are the electrolytes themselves, so they will be categorized under the electrolytic conduction. So the conduction can be of two types: metallic conduction or the electrolytic conduction. The conduction is the phenomena of passing or the ability of material to pass the electricity through it. If we talk about the metals, the best metallic conductor is silver, and for electrolytes these can be strong acids, strong bases, or strong salts. Now for the metals, if I talk, the conduction process is carried out by electrons. If it is not visible, I'll write here. So by the electrons in the metal, the conduction process is carried out, but in the electrolyte, this is carried out by the ions. Then here always remember that their conductance, suppose you are talking about G, this conductance or the conductivity is is inversely proportional to temperature, but here the conductivity or the conductance is directly proportional to temperature. It means that in the metals, when we are trying to increase the temperature, the conductance or conductivity will decrease. But in the electrolytes, when we try to increase the temperature, the conductance or the conductivity will also increase. And why does this happen? See, when we try to heat a metal, the metal is made up of its heavy atoms, and these atoms start to vibrate. Now, as soon as they start to vibrate about or around an axis, so that time on that axis when they will be vibrating, they provide a resistance to the flow of electrons. Means now the electrons will be not easily flowing as they were doing previously. But in the case of electrolytes, if we are heating it, because there are no such atoms present in the solid form, so here the ions, simply their mobility will increase, the speed will be increasing. And that's why the overall conductivity of the electrolyte will also increase on the increasing of the temperature. Now we have discussed important terms. For example, we talked about the resistance, then we talked about conductance, then we have talked about the conductivity, and then we have talked about the phenomena of conduction. Now we have to talk about another important term, and that is equivalent conductivity. Now, what is the meaning of equivalent conductivity? The equivalent conductivity is also denoted by lambda EQ, that is equivalent conductivity. So it is the conductivity of a solution which contains 1 gram equivalent of an electrolyte. There should be 1 gram equivalent of an electrolyte which is placed between the electrodes which are 1 centimeter apart. So equivalent conductivity is the conductivity of solution containing 1 gram equivalent of the electrolyte placed between the electrodes which are 1 centimeter apart. And lambda equivalent is also denoted by kappa into 1000 upon the normality n. And the units of lambda equivalent will be equal to Simon centimeter square equivalent inverse. Now the next important term which comes is the molar conductivity. So molar conductivity is also very similar to the equivalent conductivity, but here it is the conductivity which is generated by or it is due to 1 mole of an electrolyte. There it was 1 gram equivalent, here it is 1 mole of an electrolyte which is placed between the two electrodes which are 1 centimeter apart. And here if I talk about the formula, it will be equal to kappa into 1000 upon C. So can you see here that the molar conductivity is inversely proportional to the concentration, which I mean to say is if the concentration is increasing, the molar conductivity decreases and vice versa. And if I had talked about the simple conductivity, that was kappa. So let's shift it here. So it will be equal to lambda m into C is equals to kappa. So here what I mean to say is when we are increasing the concentration, the conductivity will increase, but the molar conductivity will decrease, and that is a very important concept which you need to know. The unit of molar conductivity will be what? It will be equal to Simon centimeter square mole inverse. So these are the few important terms which you need to know. In the next video, we will talk about the variation of conductivity and the molar conductivity with the dilution.